Hello, and welcome to this Twitch session that we are going to start now. We are going to talk about running JavaFX on embedded devices. So we will use a Raspberry Pi 4 to run a few samples, and we are going to talk about how it's really easy to set up a Raspberry Pi to start from the scratch. So I will try to skip the longest parts where you have to download everything and so on. And for that, I have just a video. So I will start with this video. I will comment live what we are going to achieve with this session today. So first of all, we have this docs and our docs.glounhq.com. And you just go to the Raspberry Pi section uh, and see how you can easily start developing for Raspberry Pi. For starters, you have to create your SD card with the Raspberry Pi installer. So it's really easy. You go to the Raspberry Pi docs, look for the installer, download it for your platform, Windows, Mac, or Linux, and then you have to select an OS for your Raspberry Pi. For this session, I'm going to choose a custom one because we need 64 bits. So we are going to go to this link where you can download the Raspberry Pi 4 ARM64 image. And the latest is from May. So you download it, takes a while, and then you burn the image with it. Make sure you plug your SD card with an USB device, for instance, to your laptop and burn the image. It takes a few minutes. And after the image is created, the installer will verify that everything is correct. Once you're done, you can just eject the Raspberry Pi SD card from your laptop and plug it to your Raspberry Pi. Here with me, I have a Raspberry Pi 4 with a touch-enabled 7-inch display and also an HDMI big monitor connected to the Raspberry Pi as well. So I just plug the SD card to the Raspberry Pi, and the installer process will begin. So it's very easy to set up. You just set your country, your language, your time zone, and your default keyboard preferences. And then you set up your Wi-Fi as well. It's really convenient to do that from this moment because so far we are connected to the Raspberry Pi, but later on we would like to work from our laptop or desktop machine with SSH. So we set up the Wi-Fi network and type the password, connect, and we should be good to go from now on. We finish the process, we have to reboot, and after the Raspberry Pi reboots, we'll start again, and we will go to do some final config steps. So we go to the Raspberry Pi config app. Mainly the first thing we're going to do is select command line. We don't want X for now. We select SSH, which is really important to work from a remote device like your desktop machine. And it's convenient to give more memory to the GPU. And for instance, 512 megabytes is good enough. So that's okay. We finish the process. We restart, reboot again. And from now on, we are going to work from our device. So now I'm connected to I'm going to connect to the Raspberry Pi through SSH. So it's convenient to use Raspberry Pi.local as a host name. And it's also convenient to send your SSH key to the Raspberry Pi, so you don't have to type your password all the time. So we are now connected to the Raspberry Pi. You can see that we are running directly on the Raspberry Pi. So I'm going to do some small adjustments here. For instance, the Raspberry Pi touch display needs rotation. So I set that value to 2. And I will reboot again. Once I'm back, I connect through SSH. So the Raspberry Pi is back online again. And the first thing we need to do is check if we have Java installed or not. So, well, in this case, for the Raspberry Pi 64 version, there is no Java installed. That's very easy to do now. We go to the docs, update the Raspberry Pi, so we get a fresh list of repositories, and then we just sudo apt install default JDK, and this is it. It takes a few minutes, and once we have everything properly set, we will have already Java, the latest Java 11 for 64 bits on ARM 64. So we just wait to the process to finish, and once the process is done, we can verify that Java is already installed, and we don't even need to reboot. So there we go. And now we check Java minus version, and this is it, 11.0.11 from April. So first thing, Java. Second, we are going to install JavaFX. So for that, we go to, following the docs, we go to the JavaFX product on Gloun HQ and select JavaFX 17 early access with for Linux with Arc64 and Monaco. We just download it from our Raspberry Pi, again using SSH. So we try to install JavaFX under opt. So we go to opt and extract the zip. And we see there we have JavaFX SDK 17. And underneath there are all these jars, the usual JavaFX graphic jar, JavaFX controls, and also the dynamic libraries like Glass or Prince or others with the Monaco extension. So we are done with the setup, and now we have covered pretty much Java and JavaFX parts. So the next things we can do is to do some testing, and for that, first thing we are going to do is to copy and enable the Gloun commercial extensions. If you're interested in running on embedded with DRM, you need this extension. So get in touch with us to get a valid license. So we can clone, for instance, the OpenJFX samples. We just copy the link to the repository and clone it, and we can run some of the samples. For instance, I'm going to let me switch on the camera. Okay, we have camera. Let me go to the terminal. And for now, let's use the terminal. So here we can just clone Git. Git is already installed, so we can just clone the. Let me copy it again. We can clone the samples, and that will give us the samples repository. So we can test. For instance, I have this command line modular command line hello JavaFX here, and I have already done some fixes, small fixes. But basically, what we need to do is export, enable Gloun commercial extensions, then compile. We need to compile with JavaC. So we notice we use module path to this path we already created, downloading JavaFX for Arc64. We add the modules, in this case just only need JavaFX controls. And finally we just compile the hellofx.java class to the dist folder. So this contains the hellofx class. There you go. So now we can run. So I'm just copying the command from the docs. So this is why not I'm not doing it live, because it's a long command. So now you can see the video with so let me move it top. Okay. So basically you see on a small screen you see the hello effects, which was the command we are just running. So if I go back to the terminal, just to make a, let me edit the file. And make a small change here, so you can see we are going to save. So this is usually how you edit your uh, Java files on the Raspberry Pi directly from the nano editor or V editor, whatever you use, and then compile. And then run again. So you see we have the change already visible on the display. Okay, that was an easy test. It's working nicely. So you have everything working so far to get started with your own project to run JavaFX on embedded device. So I'm going to stop now this part and there are no questions in the chat. I see there are a few people there. Hello, everybody. Uh, just feel free to ask whenever you want something, or feel free to interrupt. I hope that I will notice the question on the chat. Otherwise, people will, the Gloun people will ask me uh, to see the chat. So I'm going now to show you a little bit more complex project. So this is we call it Telematics. And let me just put it here. So, okay, there you have the Telematics POC project. So basically it's the demo we did a few days ago with the Tesla, what we call the Tesla app. It's basically a telematics proof of concept where we run some tracking to a car with some connection to the route. So we use Gloun maps to track that car or many other cars. And we also have a game. So like if you're running on your Tesla and your kids are playing with a game on a secondary screen or monitor. So you can just easily clone this project. So I'm going back to the terminal now again. Uh, so I have the projects already here. And if you notice we have a Maven project. So by default, Maven is not installed on your Raspberry Pi. So all you need to do is install it. Sudo apt-get install Maven will work. I already have it, so I will say it's already installed. But it's all you need. Then you can easily run the same as you run on your desktop machine. For instance, if you need to, we have several modules here, so you need to do Maven install clean or clean install, sorry, to install those modules. And once it downloads all the artifacts needed, the first time it will take some time to do that. So once it's done, you can run JavaFX run like you do on desktop. Here we are. All the artifacts are already being compiled, as you can see there. So we have all the artifacts installed. So now we can run for the Raspberry Pi. We have a Maven profile, and then we have just to do JavaFX run, and we are going to run the client app. So now you have to go through the command line to see that everything is running, but also you need to check your screens now. So I'm going to switch the screens now. And there we have, there you go. So you can see the map. I'm going to zoom a little bit to the map so you can see the map on the HDMI monitor. And it's updating the route from a given car. That's running with more or less 24 frames per second. And in the secondary screen, or in this case, the small screen, we have the 2048 game. So I'm going to play just by swiping. It works like this is a touch enabled screen, so it works. And also with the keyboard. I prefer the keyboard, which is faster. And you can play for a while. Then you can do regular operations like restore a session, which is empty in this case, save, share, and so on. So basically, this is the telematics POC running on two monitors with one single Raspberry Pi, and you can see the performance is really good in both monitors, in both stages. So I'm going to switch now to the second part of the demo today. So I have a few questions on it, or a few comments on the chat. Let me just give a quick look. Okay, so there's a question about cross compilation. Exactly, this is what we are going to do now. We are going to move to a Linux machine. So I'm running IntelliJ on a Linux machine now. This is Ubuntu 24.04. And I have my project here. So you can see this is let me show you, Telematics POC with the client module and the Game 2048 FX module, right? So you can see the POM here. Of course, doing it here is really more easy than doing it on the Raspberry Pi. For instance, you have your IDE with you, you have uh, your full-blown desktop with your keyboard, internet connection, and so on. So it's way better to run on your desktop machine and then move everything to the Raspberry Pi. So you can use like STP, for instance, to run on your Raspberry Pi. So what we are going to do now is we are going to build a native image, and for that we have let me show you. Here we have the client Maven plugin with the latest version, and we are going to use a profile, which is in this case the Raspberry, sorry, the Pi profile. So here we select the target, which is Linux Arc64. And here we have two convenient properties that we are going to use from the client plugin to do remote deployment. So we are going to use the host name, which in this case is Pi Raspberry Pi local. And I'm going to select a directory where we are going to copy the native image. So in this case, home Pi downloads, for instance, Telematics. And the runtime options here allow us to run like a Monaco platform and all the options we need to run with Monaco on Linux, even if it's a native image. Okay, so I could do just Maven minus profile Pi, and then client build. If I run this, it will take like 3 or 4 minutes to build the native image, so I'm going to skip that part. I've already have it here, so this is on target client X uh, 6, X 8664 Linux is the desktop version, and Arc64 Linux is the embedded version. So here we have the Telematics client. Of course, if I could try to run it here, but it won't work because the architecture is Arc64. So what I'm going to do is, now that I have it, I'm going to run client install, right? So this is going to take this host name, and this is going to take this remote directory, and it's going to copy this executable telematics client into this folder. So I'm installing it right now into the Raspberry Pi. It takes a few seconds because the image is a little bit big, and also it's doing SSH and to check the connection and create the directory if it doesn't exist. There you go, now it is copying. And it took like 12 seconds, and we are good. We can go back now to the terminal. So let me show you the terminal. I'm going to I was still running the hotspot version, so I'm going to check if under the loads telematics there is a telematics client that I just copied from my Linux machine with STP to the Raspberry Pi. So I could run it from here, or I could also go to my Linux machine and run it from there. So instead of installing, I just need to do run. So this is like running on your desktop, but on remote with SSH. So you will need to check the screens, the monitors, and see that everything is being displayed there. So if you were running the run task, we enable the commercial extensions, and we pass all these runtime options, and it is starting, and you see on the monitors, check the video feed now, and you see the car moving and the game display on your Raspberry Pi monitors. And of course, you can still play yours, your favorite game on the Raspberry Pi. So let me stop this, and you can check the logs. For instance, you can see the SSH run process we just did. It's basically an SSH with a host name here, the sorry, environmental variables sudo -e and the client name, like the telematic client app, with all the flags. So of course you can just copy this and run it directly on your terminal if needed. So you can go back to the terminal, and there you can type whatever is needed. So you could run the client. If you don't pass any option, it won't use Monaco. It will use in this case GTK, and this works if you're connected through SSH. This works usually by sending the result to your monitor through, for instance, through Xquartz. But you won't see that, so I'm going to stop it now. But that works as well if you're running through SSH, or if you're connected to the Raspberry Pi and you want to run X, you just type startx and run the client. So let me do that from here. Oh, there is no startx. Startx. There you go. Okay, no X. For now, let me do it from the Raspberry Pi. Okay. So now we can open a terminal, go. I hope you're seeing this. Let me just zoom in a little bit. And there you are. You are running now. You're running now the Raspberry Pi. Sorry, the telematics block on your Raspberry Pi on X11, right? So you have the same result, but now you have your different windows, so you can minimize them or move them around or whatever, or you can even just start and quick to the command line, and then we are back again to SSH. So pretty much this is it. Uh, you can again, all you need to do is just go through the docs, go through the JavaFX on embedded chapter, and see for yourself how easy it is to start developing for your Raspberry Pi or for other embedded devices. Okay, let me have a look at the chat and see if there are any questions. Okay, there is a question about 64 and 32 bits. So let me quickly say that usually on a Raspberry Pi you will get a 32 bits operative system. So usually you will run on 32. If you go to the docs, you see that we allow the JavaFX for 32 and also for 64. You can choose either of them. So if you're going to run JavaFX on hotspot, you can choose either 32 or 64. But if you're going to run a native image, you need 64 because we don't support 32 bits yet. So with 64, you can run JavaFX on hotspot like we have done at the beginning. And also, if you go further below, you will see how to run native image, but of course only for 64. At the beginning of this doc, you also have the links to install a 64 version. You can choose, for instance, let me open this. This is what I choose before. You have here Raspbios ARM64 from May or April or others. So I just installed this one a few hours ago. Or you can also choose, for instance, an Ubuntu image. So you can install Ubuntu on Raspberry Pi as well. You can choose your 64 version with desktop or without it. It's usually more convenient to have desktop, but it's up to you to choose the version you need and then install the packages you may need. Okay, are there any more questions? Okay, so if there are no more questions, we will have this Twitch session available for a few days or maybe a few weeks. Feel free to review it. And if you have any questions, just ping us. You know where to find us. And we hopefully will do another session if you like this one. And this is it for today. Thank you very much, everyone that attended this session, and see you soon. Bye.